Okay. Calculator allowed. You must draw the graphs on your paper. So you're going to have to sketch a graph. Even though you'll be looking at it on the calculator, you'll need to sketch it on your own paper. Label the axes and all important points. I guess we should probably talk about what important points are. All of these are going to be quadratics. So intercepts definitely count as important points. So that would be x-intercepts and y-intercepts. And there's definitely one point of a parabola that's pretty important, the vertex. So we'll be making sure we label the vertex and the intercepts. And usually the vertex and the intercepts have meanings within the problem. Like that's the highest point of a ball. Or the intercept would be where it hits the ground. Or maybe where it starts. You need to show the equations you put in your calculator and how you determine the final answers. That means you can't just write answers down even though I know you used your calculator. You need to communicate with me like what you did. And maybe the calculator did the hard math, that's fine, but I need you to show me what you did. If one or more answer is not valid for the situation, and we'll see what that means, explain why. Usually it's because time is less than 0. Maybe not usually, but sometimes. So you're solving this and you get time equals negative 3 seconds. You're like, that doesn't really make sense. I tossed the ball up in the air, and 3 seconds before I tossed it, it was doing something. Like that doesn't mean anything. All answers should be justified with graphs, equations, explanations. Again, we're trying to just make sure you understand, even though you have a calculator, you can't just write down 12, 7, negative 3, 43, 57, done. Like, I got to know where those numbers come from and what they are. If you need to round, we always round to the thousandths. So that's the third decimal place, 3 decimal places. And even though you're a long way from taking the calculus AP test, the calculus AP test is always 3 decimal places. So we figure we'll just start now and get used to always doing 3 decimal places. That way 2 years from now you'll just think that 3 decimal places is the normal thing to do. Okay, number 1. David kicked the ball into the air. The function of the height of the ball in feet is given by h equals 64t minus 16t squared. So probably what most of you want to do is to graph that and see what that looks like, and that's fine, so let's do that. So let's grab a calculator, and go to y equals, I try to cruise through the stuff that I think you know, but slow down on the stuff you don't know, but, okay, too fast. Y equals, top left, y equals. Have you guys not used these calculators before? Are you used to the Inspires? Is that the deal?
I used the Inspires.
Oh, my batteries are low. That's okay. It'll still last a while. Hopefully. So go to y equals, top left, and then we'll type in our equation. I'm not going to use t. I'm going to use x's just because that makes it easier. So 64x minus 16x squared. Find x. All right, everybody got 64x minus. Yeah, x is toward the top left. Xt, theta, and n. And the calculator knows which one you want, because if you're in a different format, like stuff that you may never get to, it will automatically use t and theta and n when you need it. Okay? If we want to graph that, What button do you think we should hit? Graph. So top right, let's hit graph. Let's put us all on the same scale to start with. So go to window. Nope, sorry. Go to zoom. And then scroll down to standard. If you're ever stuck on a weird scale, like you grab the calculator and somebody else had zoomed way in or way out, and you're like, what is going on here? Zoom standard puts you back to normal. -10 to 10, -10 to 10.
I still can't see it.
So everybody should be looking at that. Because we've all got the same window. Zoom standard. You're good though. You can see that. Zoom standard.
What did you do?
I don't know what X you use. You may use it.
I used the link XTEN.
All right, everybody looking at that?
Yes.
So I guess that's kind of helpful, but it also goes way off the graph, right? Like, I know it's a parabola. In fact, this is where maybe some work ahead of time might have been useful. Like, I know this is a parabola, and I know it's a downward parabola. So I know it should look something like that, even before I graph it, because it's a -t squared. Okay, well, how high is that thing? We have to sketch it and label stuff anyway, so let's find the vertex. The x-coordinate of the vertex. How do we find the x-coordinate of the vertex? -b/2a. This one's kind of tricky because what's b? 64, right? It's out of order, but a is always the x squared coefficient, b is the x coefficient. So -64 over 2 times -16. You've got a calculator. Hopefully you don't need it to do 64 divided by 32, but you do you if you need it. So the x-coordinate of the vertex is 2. How do I find the y-coordinate of the vertex? Plug it back in. So I want h of 2. So I want to plug 2 back into the equation. I have a calculator, so I can just type it in. It's not really that hard. But I could also use the table. The table will give me the table of values. So that's second graph, second table. And then I can see right away that when time is 2, the height is 64. Yep, sorry. So I'm looking at my graph. Table is top right, so second table will get you the table.
Got it. Okay.
And then you've got a list of points there, but the one I'm looking for is h of 2 is 64. You know what? I guess while we're there, we're going to need those eventually. Eli, what'd you say you found? 0, 0, and 4, 0. So we happen to find some zeros there. And then 2, 64. So I've got some intercepts. I've got a vertex. That's certainly enough to do a little sketch of this graph. Thank you. Okay, what do we need to answer next? We've got our picture. Part A, draw the graph of this function, label the axes and important points on the graph. Okay, so on my calculator this is the x-axis, but in this particular problem, what axis is this? Time. So it's still the left-right axis, but it's measuring time. It's the dependent variable, so it's time. And what about my y-axis? What's that measuring? Height. So height versus time. Draw the graph, label the axes, and important points. So 2, 64, that's an important point. 4, 0, and 0, 0, my intercepts. All right. I mean, I can make my calculator look like that, but now that I've got the picture, I don't really need the calculator graph. So let's just keep working through these. Draw the graph, got that. Label the axes, important points. Okay, so we're done with part A. How long was the ball in the air?
4 seconds.
How do you get 4 seconds?
Because when it left
Yeah, okay. When it left the ground to return to ground. Yeah, that's how long it's in the air. When it leaves the ground, when it returns to the ground. How long would be the time? So maybe we should say time from when it left the ground to when it returned to the ground. So yeah, 4 seconds. It left the ground at 0 seconds. It was at the ground 4 seconds later. So my answer is 4 seconds.
Do we have to write out that sum?
That one I would say you got to write out something to justify what you're looking at. You don't have to write it out exactly like that.
Okay, so we can't just put the answer there.
So I don't want to just see 4 seconds. I want to see some kind of explanation. Again, your words don't have to exactly match mine, but it would need to say something about ground or h equals 0. What was the maximum height of the ball?
64 feet.
64 feet, but I need to say something that justifies that. I agree.
It's where it reached its peak.
Okay. Let's use, that's not wrong, let's use a more mathy word. Vertex. And what about the vertex? It's the y-coordinate of the vertex. Or the h-coordinate if you want to say h. Y-coordinate of the vertex. So again, give me some explanation of how you knew that. Like, what were you looking at?
The top of the graph.
The top of the graph. But then say it with a little bit of mathy language to sound fancy. When did the ball reach its maximum height? I guess when is the... So that's time. 2 seconds. How did you know that? X-coordinate of the vertex. Okay. How high was the ball after 1 second? I don't think that one's on my graph.
48.
I mean, it's kind of on my graph. It's right there, but I don't know what that is. You guys are saying 48. Where'd you get 48 from? Okay, the table's fine, because I know you have the table. So make sure you communicate what you found. H of 1 equals 48. And you could just say parentheses table. Like I used the table to find that. So you could plug 1 into the equation, but you got a table, so that's easy enough. You can use the table when you can, because... Okay, 2.5. I'm going to have to plug that one in. That one's not on my table. Now, there's a way to adjust the table to put it on the table, but I think it's more complicated than it's worth. So let's just plug in 2.5. I just hit exit to get out of that second quit. There's 2 ways to do this. There's the straightforward way. I guess I'll show you that way first, because that's probably the safest way. Just plug in 2.5 in the calculator. Right? You got a calculator, so you don't have to worry about big numbers or decimals or whatever. 64 times 2.5 minus 16 times 2.5 squared. So that's plugging in 2.5, and we get 60. And probably a good idea to like check your graph to see if that makes sense. All right, at 2.5, I mean, I can't tell exactly from my picture, but 60 makes sense. It's just a little bit less than 64 because we're just a little bit past the highest point.
So will we put calculator?
You don't have to tell me you use the calculator because you show me what you did.
Oh.
And I know you use the calculator, that's fine. Okay, I'm going to show you another way because sometimes it's helpful, especially if you have to plug in quite a few values and especially if your equation is tricky. Basically, your calculator understands function notation. Your calculator knows function notation. So if you could figure out how to ask your calculator for y1 of 2.5, it would just give you the answer because it knows that's what you're asking. Okay, so to find y1, and again, you don't ever have to do this. You could always type it in. It's just sometimes if the typing in is long, it's easier to do it this way. y1 is a variable, so let's go to vars. You see vars on the calculator? It's top right-ish. And if you can remember vars, there's quite a few buttons, but as long as you remember vars, you can get there from just knowing vars. Because what kind of vars are we looking for here? Look at your options. I pressed vars.
Table.
We already looked at the table, and 2.5 wasn't there. We're looking for a y var, a y variable. So let's go over to y variables. Now our options are function, parametric, polar, on, off. Function, because the other three you're like, I'm not even sure what those are. So I don't want those. Function. And then our equation is in y1. So there's a lot of buttons. So there's y1. And we'll just type this in like we're used to writing things, like function notation. y1, parentheses 2.5. Your calculator knows that that means go get y1, plug in 2.5, and tell me the answer. So I should get 60 again. That's pretty cool. Especially, again, this one wasn't a bad function, so not hard to plug it in. And plugging in 2.5 wasn't that big a deal. But if you had a really long function and you wanted to plug in 4.78256, you don't want to be typing that, all that stuff. You want to do y1 of 2.5. So you're back on the main screen. I'll do it one more time. I'm looking for a var, so I go vars. What kind of vars do I want? Y vars, because this is a y thing. Definitely function, because the other three are weird, at least for us for now. And y1 is where I put that equation. Like later on, it might be more complicated and have 2 or 3 equations. You'd have to pick the right one, but I've only got one, y1. You know what? What's the next one we should look for?
5.
I'm going to do h of 5 since I've already got this pulled up. I suppose I could go to the table, but it's already pulled up, so h of 5. Negative 80. So where are you, Eli? Are you?
I go to bars.
Wait, are you on the main screen to start with?
How do I get there?
Second quit. Always take you back to that main screen.
And then I put bars.
Now go vars and find your way to y1. Kinley?
So if we were to use bars, would we have to put bars in
No, but you can write this because this is exactly what you put in the calculator.
Oh.
Yeah, that's okay. I know that your calculator can do that, so if that's what you typed in the calculator, then that's good enough for showing your work.
So it's only if we just put an answer rather than the equation to the answer?
Right.
Okay.
Eli, did you find it?
Yes.
Okay.
Negative 80.
Okay.
But this is 0.
But hold on. Read this question again. How high was the ball after 1 second? Negative 80? Why can't that be right? I mean, unless we're throwing it off a cliff or something. Negative 80, let's say no. We already hit the ground. So this is where you have to have your brain engaged. You can't just be like, oh, calculator said negative 80, move on. Like, no, you get to use the calculator, but you have to understand what's going on in the problem rather than just writing down whatever the calculator says. How high was the ball when it was kicked? Where'd you get 0 feet from? I'll say it's the height. Actually, you could just say h of 0. The height when we started. The height when it was kicked is time equals 0. So h of 0 is 0. Either plug it in or look at the graph or look at the table. Do y1 of 0. However you get there, h of 0 is 0. So this thing started at 0. I suppose you could also say it's the y-intercept, because that's where we start, the y-intercept. Okay, so far so good. When was the ball 45 feet high? Show your work algebraically, then round the answer to the nearest thousandth. Let's look back at our picture here. Let's see. At 1 second, it was at 48. So it looks like I'll have 2 answers. Haven't really found an answer yet. I'm just trying to think ahead. Like, what kind of answers will I get? Something a little bit less than 1. And since this thing is symmetric, probably something a little more than 3 over there. So I want to know when the parabola is equal to 45. So I want to know when the parabola, 64t minus 16t squared, equals 45. Okay, how would you like to solve that? Sure. Well, those are weird numbers, so I'm guessing it doesn't factor. Square root method only works if there's not a b term. You're going to have to use the quadratic formula. Or complete the square, but that'd be really weird because you have to divide by 16 and then you'd have all kinds of weird fractions. So I'm going to use the quadratic formula. I usually like it if my a term is positive. So I'm going to move the 16t squared over. I'm also going to put these in order just so that it's less likely I mess up who a, b, and c are. Right? I mean, it's fine to write it out of order, but then you might mess who's A and who's B and who's C. So worthwhile to put things in the right order. You definitely have to have it equal to 0 or else your signs will be off. Kinley?
Wait, did you subtract the 45?
I left the 45. I moved these two to the right because I wanted this guy to be positive.
Oh, I see.
So get to sing the song. Well, I guess it's t equals in this case, but same song. T equals, what's negative b going to be? Positive 64. Plus or minus the square root of, I do not know what negative 64 squared is. Minus 4ac all over 2a. That's ugly, but I have a calculator. You think I should be able to do 64 times 64 in my head? Yeah, sorry to let you down. I just highlighted that because I'm going to do that first in the calculator.
You're just hiding your true skills.
I don't want to embarrass you guys by showing off. I know if I square negative 64, it should be positive. So a lot of times when I go to the calculator, I'm not even going to include the negative for fear of messing it up. I'm just going to go 64 squared because I know that's supposed to be positive. Minus 4 times 16 times 45. So right now we're sort of in the, show as much work as you need to make sure you get the right answer. I guess I'm ready to go to the calculator now. There's going to be 2 answers, but we're okay with that. We expected there to be 2 answers. And the calculator, there's not like a plus or minus button. The calculator can only do one thing at a time. So I'm going to have to split this into 2 pieces. 64 plus and 64 minus. And so this is what we mean by show your work algebraically, but use the calculator to do the whatever the square root of 1216 is.
Why would the plus minus be
I could have split it into 2 pieces. Like, I'm just showing what I'm going to put in the calculator. So, I mean, you're right. If I only wrote one of those, that'd be wrong. But I'm going ahead and splitting them up and showing both of them. Have you seen the fraction bar in the calculator? You can use parentheses, but some people mess up. In fact, let me just show you the mess up version. 64 plus square root of 1216 divided by 32. That's going to be wrong. That is not the right answer. Why is that calculator thing not right? Yeah, I got to divide all of it by 32. So I could put it in parentheses. That would fix it. But what a lot of people like better is the fraction bar. Of course, now you got to know where it is. So to get the fraction bar, that's alpha F1. So green button and then very top left button. And again, this is one that you don't have to do this, but it's very convenient if you have a fraction bar. Then it's super easy to know who's in the top and who's in the bottom. So alpha F1, that first option, what do you think N and D stand for? Numerator and denominator. So N over D. And then it's really easy to see that you want 64 plus square root of 1216 in the top and 32 in the bottom. And then you don't have to worry about parentheses because you've got everything in the right spot. 3.090 for thousandths. And that fits what we thought, right? We thought it'd be a little bit more than 3. Speaking of calculator tricks. Right, so I looked, there's my third decimal. So I look one past it. Right, that's bigger than 5, so I round up, and that bumps that to a 90. I can type all that in again, or you guys may have known this, like you can scroll up and just select or hit enter on that previous entry, and that copies it down. And then all you gotta do is go change the minus sign. Whoops, I can get there. So that's really helpful if you've typed a really long equation in and you find a mistake. You're like, dang it, I gotta go fix the mistake, but I don't want to type it all in again. Well, just go grab it and fix what you need to fix.
Can you do the process for the thing one more time?
Yeah.
For the fraction bar?
Oh, for the fraction bar.
Yes, please.
Yes. The fraction bar is alpha F1. So green button, and then very top left button is F1. And then there's lots of options there, but the very first thing is numerator over denominator. So you press that, and it gives you a fraction bar.
Okay.
And then you can use your arrows to put whatever in the top and the bottom. Okay, so I got my 2 times. They both make sense. Nothing's crazy. I don't have a time that's negative or a time that's like after it hit the ground. Like, again, make sense of what your calculator gives you. Don't just say, well, the calculator said it, so it's got to be right. Like, no, use your brain in addition to your calculator. Okay. Completely optional. There is a way to check those answers. A couple ways to check those answers. So I'll show them to you. We won't harp on them because you don't have to do this. But I would really like to know, or maybe I want to see if my answer is right. Well, you know what? Before I can check, I'd like to have my calculator show me a better picture. So I need to change the window that I'm looking at. That kind of gets to part H. What is a reasonable domain and range? Well, domain is usually X, but what is the left-right variable? What is the independent variable for this problem? T. So be careful. Yes, domain is X, but a better way to say it is domain is the independent variable. You don't, but that's just me thinking through the process here, because when I think domain, I think X, and then I'm like, wait a minute, I don't really have X's in this problem, I have T's. And what what span of T values would be a good span for this problem? 0 to 4. Because before 0, that's negative time, that doesn't really make sense. After 4, we've already hit the ground, so that doesn't really make sense. So 0 to 4 is a good, that's why it says reasonable. The graph goes on before and after 0 and 4, but it doesn't really have any meaning. Range, what do you usually associate with range? What variable? Y, but we don't have Y's in this one. We do have an up and down variable, though. H, a dependent variable. And we've got a decent picture here. What's a reasonable range for H values? 0 to 64. Our graph goes on further down below, but that's like underground, so that doesn't really matter. I only care about 0 to 64. Now, let's take that and let's adjust our window. You know what? I'm going to kind of include this in the optional as well here. So, the optional box here. But some of you are going to like it because you can see your answers nicely to do this. Okay, so let's go to window. It's on the top there. That's where you adjust basically your domain and range, not of the function, but of the graph. Like how far left and right do you want to look? How far up and down do you want to look? And we kind of already answered those. So X, we want to look from 0 to 4. X scale, the SCL is the scale. That only matters if you're like going from 0 to 10,000. You probably don't want a tick mark every 1. You'd like a tick mark every 1,000. But if you're going 0 to 4, 1 is fine. Y-min, we said we'd go 0 to 64. I don't know that I want to see 64 tick marks. So if you want a tick mark every 5 or 10, this is where to change it. It doesn't matter what you put there. It won't really affect the graph. It only affects how many tick marks there are. So I'll just leave it at 1. So let's see what that looks like now. Look at that. There's our...
Did you just press enter?
I pressed... What did I press to get there? I pressed graph. Yeah.
I see.
It's a rainbow.
Now, sometimes people don't want it to fill up the whole graph. They want some like margin around there. And so you go -1 to 5 and maybe -5 to 70. That way you get a little zoomed out and see a little bit more of what's going on, even though you know that the ball doesn't really go below ground or start at negative time over here. Okay, so how to check, back to our previous, when was it equal to 45? So there's a couple of options here. One option is trace. See the trace button? Well, it's on the top row there. You hit trace, and then you can kind of arrow around. The trouble with trace is it doesn't always land exactly where you want it to land. Like we were looking for y equals 45. And I can't get there exactly, but I get pretty close enough to make sense of my answer. When y is 45.16, time is 0.91, so yeah, I feel pretty good about my answer over here. Oh, yes, because trace is going to depend on like your window. So yours may not be exactly like mine. But it doesn't matter because neither of us are exactly at 45. So trace is nice, but it's not perfect. You can't get your answer from using trace because you can't make y land on exactly 45. Let's go check the other one. It's supposed to be around 3.09. Let's see how close we can get to 45 on the other side. 45.16. It's close. Time 3.08. That's close to 3.09. So again, trace is nice, but it's only for checking. It's not going to give you the answer. It's going to help you feel good about your answer. So I don't. Sorta. It gets close. But it doesn't give you your exact answer. So it's nice, and you can make sense of your answer, right? If you got 7 or 0.2, hopefully you can go to your graph and trace and think, wait a minute, that doesn't look right. So trace is, I hesitate to show trace because there will be people who use trace and try to use that as their answer. But you can't make it get to exactly 45. At least with trace. With other things you can. Okay, so again, there was nothing new like algebra concepts there. It was more about the buttons we push. Let's go back and see what buttons did we needed vars, although we didn't really need that one. We definitely needed the y equals in the graph. Guess I didn't even say that on there. Y equals and graph. We used the table somewhere. So today is really more about getting used to the calculator, knowing where the buttons are, knowing the things that it can do. But you guys were good on the theory on that, which is why we hold off on the calculators for a while. We want you to know the math and then use the calculators as a help, not as a crutch. Okay, let's turn to number 2. Yes, sir?
Have you ever thought how calculators feel about you? Because you constantly push its buttons.
Very nice. Number 2. A soccer ball is kicked from the ground with an initial velocity of 96 feet per second. Remember, I don't know that you're not gonna need to remember this, so we would give you that if we need you to know that. V0, that's the initial velocity. You'll know this more in physics next year if you're in physics. Well, that 0 means initial, V for velocity. So what do you think H0 represents?
Initial height.
Initial height. The 0 means initial, the H is for height. So initial height. Okay, so let's rewrite that equation but fill in some pieces here. So h of t equals negative 16 t squared. What's the initial velocity? 96. Because it just told me the initial velocity is 96. So we put 96 in for V0. What's the initial height? It never says the initial height is
0.
Why you say 0? You're right.
Just have to go.
From the ground. So if you're on the ground, that means your h is 0. Obviously, you don't need to write plus 0, but that sort of emphasizes that you're starting at 0. Okay. I want you to sketch a graph and answer those questions. So it's kind of the same thing as number 1 with a different formula in there. So see how far you can get on your own on that one. if I say, it says when the ball reaches maximum height, and I say 144 feet,
No, it's when.
it's when, right? It's when. So that means time. So when is time? So, I mean, I was looking at the right spot, but time is 3 seconds.
Oh.
And then what is the maximum height? There's where the 144 goes. Okay, let's do number 3 kind of together. Question?
Can we put a table for that to just Or will we pull it for
Vertex.
Oh, that's right. It's the X and Y vertex.
Vertex.
like for A? Would you take
Definitely for A, yes, yes. Okay, number 3. Do you see what makes 3 different? It has an initial height. That's going to mess up some of our symmetry, so we're going to have to be careful with number 3. Write the equation. Okay, what's the initial velocity? This one just spells it out for us. 120, so plus 120t, plus, it even just says, an initial height of 3 feet. So maybe this was like a punt, and when the kid kicked it, it was already 3 feet off the ground when he kicked the ball. Solve the equation algebraically. I'm not sure what it wants me to solve there. I think it means set it equal to 0. Find when h equals 0. I have no idea if that factors. I don't want to find out if it factors, because I don't want to sit there and I can't imagine that it factors to get to 120. So what am I going to do instead?
Quadratic.
Let's do quadratic formula.
You write your T's very here, because I get confused there.
Well, I'm trying to make them not look like plus signs.
Yeah.
So t equals negative b plus or minus the square root b squared minus 4ac all over 2a. Video. We get a negative number because when we kicked the ball, it was already 3 feet off the ground. So mathematically, it was at the ground 0.025 seconds before we kicked it, but that doesn't really make sense. So we can throw that one out because that's beyond the domain of what we're concerned with. So mathematically, yes, but problem-wise, no, that's not right. Give the approximate answers. Well, really only one. How will I find when the ball reaches its maximum height? The vertex. When, that's a time. Negative b over 2a. Negative 120 over 2 times negative 16. And again, you got a calculator, so. So 3.5 seconds. When, that's a time, so we found that. What is the actual height? So how do I find the height? Plug in 3.75. And that's the weird one, so that won't show up on the table. Right? So it's somewhere in between. Oh, you know what? I don't think I put this one in even. Negative 16, x squared, plus 120x, plus 3. So the table's not going to help me because 3.75 is not on the table. So I can either plug it in or I can do my magic VARS trick here. Y1 at 3.75. That basically tells the calculator to plug it in. 228. then F, this is easy.
I think I'm cooking in with class.
What am I going to do to find the height of the ball after 1 second? Plug in 1.
Just do bars again, just for 1 minute.
You could do vars, but what might be even easier because they're nice. Table would probably be easier. You could do vars again as well. Either way. And you don't even have to go back and through all the steps. You can do that thing where you scroll up and grab y1 of 3.75 and then just change it to 1. So there's y1. And then go do it again, but now put in 2. That should be the same thing the table says. Yeah. So multiple options, or the worst option, I guess, would be typing it all in, but I guess if you didn't trust your calculator. Yeah. Okay, we are going to skip number 4 for now. 4 will be a Friday problem. But let's look at number 5. We only got 2 more. 20 minutes. Yeah, we may finish this off. On Friday. Like here's my note to self. Today we're going to do 1, 2, 3, 5, and 7. That says start. So like I did 1, you kind of did 2 and 3. I'll do 5 with you, and I'll assign 7. And then Friday we'll do the others. This worksheet is kind of weird because these problems are different than the others. So they should not really be on the same worksheet, or at least they should be grouped differently. So bypass 4 for now. We'll get that on Friday. Skip ahead to number 5. This is where it's a combination of your brain and the calculator to solve this thing. A rectangle is shown with an area of 160 square feet. Write the equation for this situation. Okay, well, how do I find the area? Forget about the x's. Just how do I find the area of a rectangle?
Times 1.
Both dimensions, whatever they are. Height, length, width, whatever. A, B, like length times width. So x plus 3 times x plus 6 equals 160. Let's see. Write the equation for this situation. You know what? I guess that's okay. Since I'm about to use the calculator, I don't really even need to multiply that out. I could. Just don't have to. So I'm going to... This feels weird, but it's not wrong. I'm going to subtract the 160 over. Set it equal to 0. Sketch the related graph. Label all the intercepts and their ordered pairs. So the related graph would be, just sketch y equals that thing. And again, if you want to multiply it out, you can. But you're going to the calculator, so why bother? Why risk messing something up? Why not just put it in like it looks? X plus 3 times x plus 6 minus 160. Now, I guess I have no idea what this graph is going to look like, so I'm just going to hit graph and hope for the best here. Yep, that's what I figured. I don't see anything. So I'm going to go zoom standard, right? If you ever get to where, like, I don't see anything, zoom standard puts you back kind of at normal. Hopefully we see something on this graph. Okay, there's part of the graph. Let's see. Y equals. Is this parabola opening up or down? Why do you say up? I agree with the up.
Because it's showing multiply, you get x for the...
Yeah, the x squared would be positive. I don't know what else is going on, but... So I know it's up, which means... I like doing this graphically. Can't see everything. Where's my other 0? Can you tell by looking at this? Is my other 0 over to the left or over to the right? If I know this is an upward parabola, it's got to be over here on the left. I can tell by the way that thing's slanted. So I need to change my x min to more min. Negative 20, maybe? I'm just guessing now. There it is. Because I want to find those zeros, because those zeros will make this equation true. I want to find those zeros. Oh, I want to do it this way. You know what? Let's do it. Let's don't do it the graphing way. Let's do it the other way. Forget this. Let's multiply it out. X squared plus 9x plus 18. I mean, yeah, we're doing geometry because length times width equals area. That's geometry. So forget the graph. Let's just do the quadratic formula again. I have to do a little bit of work, but not much. So, good old quadratic formula again. X equals negative b plus or minus the square root. B squared. Finally got a b I can square in my head. Ben, are you proud of me? I know what 9 squared is. Minus
I know it also.
4ac.
It would be impressive if you did like an 81 squared. But you just did it right. Use my little fingers. Nice. 90.
For 9 squared, not for 81 squared. So here's where some of you are going to put pieces of it in the calculator and write things down. Others of you are going to just shove it all in there and just be careful. I'm going to use the fraction bar, and I'm going to go just put all of it in there. Where's the plus minus button on the calculator?
There's a plus and minus button. Now you're age bait, yeah.
I wish. Although that would be weird, so maybe I don't wish. So negative 9 plus 81 minus 4 times negative 142 over 2. Right? I do a little bit of math in my head because it's just easier in my head than in the calculator. Right? I know what 2 times 1 is. I don't need to type that in. So one of my answers is 8.238. But there's another answer. And the easy way to get there is just go grab that first statement and change the plus to a minus. A minus sign, though, not a negative sign. Those are different. Negative 17.238. That gives us the z. That solved the equation. Now I know what x is. But one of them is negative. And the fact that the x is negative isn't a problem. But when it says find the dimensions, if I do negative 17 plus 3, negative 17 plus 6, that's not, I can throw that one out. Like, how many solutions are there? There is one solution. Because you can't have negative lengths. Right? You can't have a box that's negative 17 long. I do need to be careful. I haven't answered the question fully yet. What does C say? Find the dimensions of the rectangle, so I need to find what x plus 3 is.
So we're just skipping all what we asked.
Yeah, because we didn't want to label the graph. We just did the quadratic formula. That was easier.
Oh, okay.
So that's still in my calculator, so enter plus 3 I probably didn't need a calculator to add 3 to that. X plus 6 is 14.238. I'm doing 3 plus x and 6 plus x. Because it didn't ask me for x, it asked me for the dimensions of the rectangle. You may. This is a big deal in calculus, and my kids are going to mess that up tomorrow. Because they do all this work, they find something, but then the question was, okay, yeah, x equals 12, but what was the height of the rectangle, or what is the area of the rectangle? So make sure you read the questions. Okay, the only other one for you, and we'll start it together, is number 7. A rectangular animal pen with area at 1,200 meters squared has one side along a barn. The other 3 sides are enclosed with fencing. Maybe colors. So it's like I get a free side. I didn't have to fence one side of this barn, or one side of this pen. Area is 1,200. Draw a picture. Okay, I've got a picture, but I'd like some labels on this thing. Let's say these lengths are x. All right, it's a rectangle, so they have to both be x. Now, given that there's 100 meters of fencing, can you figure out how long this side is?
100.
Not 100. I started with 100. I used x of it on this fence and x of it on this fence. How much fence is left?
Yeah.
I'm going to have to answer in terms of x.
1/2 x.
I started with 100, and I used x there, and I used x there, so the amount of fencing that's left is 100 minus 2x.
This is some weird geometry.
Wait, what are you saying? Are you using
Or you could just add those. Now you can add those 3 sides up, and you get 100. X plus 100 minus 2x is 100. Coming up with that is the hardest part. There's another way to do it. Given your reaction, maybe we should have done it the other way. If I just call that side y, then what has to be true about x's and y's? X times y is 1,200, but what about the fence situation? There it is. Y plus 2x equals 100. That side plus those sides equals 100. Which now means that that side is 100 minus 2x. So we get there one way or the other. Because it told me there was 100 meters of fencing. So these 2 sides plus this side has to equal 100.
Oh, okay. I was thinking about the nature of the barn. Okay.
And I don't, the barn is a free side. I don't have to use the barn
Okay,
side.
I thought you were saying in respect to, okay.
Wait, you're saying that whole thing is y, not like 100x minus 2?
Well, it's the same thing. This length is y, and y is 100 minus 2x.
Well, can you just say it's just y?
You could,
Okay, that makes so much sense.
to just call it y,
Yeah.
but then you have 2 variables, and so eventually you need to solve for y to figure out what that side length is. Okay, area is 1,200. What's the area formula? Geometry all stars. Length times width is 1,200. So what's the length and the width of that pen? Perfect. X and 100 minus 2x. So I guess that's the equation, is x times 100 minus 2x equals 1200. Find the dimensions of the pen. I'm going to have to solve this thing. So 100x minus 2x squared equals 1200. So I need to make it equal to 0. You can move it all to the right or all to the left. Got a preference? Do you want the 2x squared to be positive?
Yes.
Okay. So we'll move it all to the right, and I'll put it in order so that I don't mess up my a, b's, and c's here. So 2x squared minus 100x plus 1200 equals 0. And now I'm ready for the quadratic formula. Although you could do one more thing to make life a little easier on yourself.
Divided by 2.
You could divide by 2. I mean, you're going in the calculator, so I guess it doesn't really matter, but x squared minus 50x plus 600. So now you're ready for the quadratic formula, and then make sure you find the dimensions of the pen. And that's all there is left for today. So if you can do that in 5 minutes, then you're done. If you can't do that in 5 minutes,